Bendy limbs are controllers that allows us to reshape limbs. As we can see here, we can resculpt the shape of any limbs with these bendy controllers. And in this video, we're going to take a closer look how we can add and configure and control the Bendy Limbs controllers. Let's start with a blank new scene. And we'll see that out of all the possible systems that we can add to AdvancedSkeleton, the one on top is called Twist Bendy. So essentially, it is two systems in one. It's the twist system that allows for the typical twist effects that you see in a forearm, and it's also where we will add the option to have bendy controllers. What we can do is create a super simple AdvancedSkeleton rig by just plotting the joints. So we'll just create one bone and go ahead and say build AdvancedSkeleton. That builds an AdvancedSkeleton rig from that single bone. Then we can toggle back to the fit skeleton. This time we'll add the twist bendy fit attribute to our joint and hit rebuild. And we can see that this time we're getting all these extra joints in between, and we can take a look at how they behave when we rotate the controller. One way to look at how joints behave is to go into display section and turn on joint axis. That shows us the orientation of each joint. However, there's another method I prefer that shows the joint behavior even better, and that is under the section called Geometry Polyboxes. And the last one here is Box Skin. Now this one creates a box for each joint, and it becomes very easy to see the behavior of the joints. Alright, so now we can see that we have these three joints, and they all do follow the controller as we bend it forwards and backwards. However, if we twist the controller, you see that we're getting a distribution of the twist down the length of this bone. Okay, we can again go back to our fit skeleton, and we can see that when we added the twist bendy fit attribute, we got some attributes over here with some options. One of them is twist joint. So instead of 2, let's increase this to 10. Again, hit rebuild and see the box skin. Now it becomes even more obvious to see the behavior that all these joints will follow the bending forwards and sideways, but in twisting, it will distribute the twist. And again, we'll go back to the fit skeleton and we'll look at the other option here, which is bendy joints. When we turn this on and hit rebuild, this is where we're getting the extra bendy controllers. So the FK controller is still doing the same, forwards, backwards, it's for following with the distributed twist. In addition, we have the ability to, in a way, sculpt how the distribution of these joints are happening. Okay, now instead of looking at this simple example, let's go ahead and look at a full biped. And one thing we can do, we can import the fit skeleton template called Biped Bendy. Now this template has the bendy joints option already turned on for the arms and legs. The default is still 2 joints. We'll just crank that up to 10 for demonstration purposes and build the AdvancedSkeleton. And I'll also show the box skin so we can see the joint behaviors. And let's take a closer look now at how the bendy controllers behave and the options that comes with them. So we can move this controller, which essentially drives a curve, which again drives the distribution of the underlying deformation joints. First option that you have here on the channel box is called parametric. Now, what parametric does, it is basically saying it's going to be a parametric distribution of the placement of the joints along this curve. And a way to kind of more easily understand this is if you take a look when we're moving this up and down the length of the limb, we do not see much compression and stretching going on. And that's because the parametric attribute is on. If we turn that off And we can now see that that takes into account the amount of stretching and compressing that's happening to the underlying curve. Going back, turning parametric on, you'll see that this is now back to being evenly distributed distance between the joints, no matter the shape of the curve. And to see this even more clearly, we can hit go to build pose. We'll turn off parametric and move the controller up and down in the direction that is aligned with the limb, and you'll see compression and stretching happening. If we turn parametric on and do the same, you'll see this will at this point have no effect. And again, that's because even distribution is ensured. And to see any effect on the curve with parametric on, you would need to move it in other axis than the one aligned with the limb. And there we can see how that works. All right, let's hit go to build post and look at the next attribute here. It's called microvis, and basically that is setting the visibility for what's called the microcontrollers. I'll turn this on and we see we get a whole bunch of additional controllers. And if we move that main bend controller again, we can see that there's levels of controls happening here. Moving the bend controller is essentially moving the microcontroller, and the microcontrollers are moving the joints. This gives us a controller for every joint that allows for tiny micro adjustments per joint. So at this point, we have 3 levels of control going on. We got the highest level, which is the FK controller itself, controlling the limb. Next level down is the bend controller, controls the shape within what's been set by the FK controller. And then the finest level is these microcontrollers that essentially applies control on a per bone level. All right, back to build post, and we'll turn off the microcontrollers for now. And I'll quickly mention something related to twist rather than bend, and that is most users are familiar with twist distribution on the forearm, because it's a very obvious place where the underlying autonomy is actually 2 bones that roll around each other. But this kind of a distributed twist effect will happen on other places as well, such as the upper arm. If you were to rotate the upper arm, you can see here there is a distribution of twist happening from the shoulder down to the elbow. Now, in real anatomy, in this case, the twist distribution is not caused by the same dual bone rotating around each other, but rather than the shoulder bone will rotate hardly, which we can emulate here by selecting both this. The shoulder bone will rotate a hard rotation as it is a ball joint, but this way the skin is attached means that the effect seen on the skin is not a hard deformation for the twist axis, but rather a distributed effect. So we got the distribution happening automatically from the FK controllers. And by the way, both the twist and the bend applies both to FK and IK. So if we quickly go over to IK and make some adjustments to the IK controllers, you see we'll have the distribution of the twist happening in the same way. And we have the ability still to apply the custom shaping of the limbs with these bend controllers. And the bend controllers are also points where you can control the scale, and the scaling will taper in between the controllers. Now, another thing is that for each limb, you get 2 controllers. You get the first one called bend 1 and the second one called bend 2. So this is shoulder bend 1, elbow bend 2. We got elbow bend 1 and elbow bend 2. In the case where one bendy limb is followed by another, here a shoulder followed by an elbow, the bendy one for the elbow is actually connected to the end of the bendy shoulder. So twisting here will also apply twisting upwards. And another thing about the bendy limbs is that the underlying system is a curve that's driving the bones. So when we're moving the bendy controller, it's driving a curve, and this curve can be found quite easily if we go into the outliner. Just open the top node, go into the motion system, and you'll see there'll be a group for bend system. And under that, we have bend curve. Here are all the curves To see them more clearly, we can select that top node and say turn off joint visibility. And there we see the curves. You can see as we move this bendy controller, that is essentially driving these curves. Now, given that we have easy access to this, we can do some interesting things with them, like applying non-linear deformers. So if you wanted to have some sort of effect of a wave running through any of these limbs, say you wanted some breakdancer moves happening on the arms, you can select the curves that controls the arm. So let's go ahead, select the right elbow bend curve and the right shoulder bend curve. We'll then go into deformation and say add a non-linear sine wave. And let's apply some altitude to that and orient it to match the limb. And we can see that we're getting this wave running through the limb because that's directly controlling the curve. And if we now apply offset to that wave, you see we start getting this wave behavior running down through the limb. Now, for even more detailed control of attaching nonlinear deformers to controllers on a rig, there is an option in the selector under anim called Deformable, which makes controls able to have any deformers applied. And there's a separate YouTube tutorial on that topic. And that's it for this video about the bendy controllers. I hope you have enjoyed this video, and I'll see you next time.